Okay, so let's look at a solution. So again, this is an impulse problem. And so we can write that the change in momentum of the ball is going to be equal to the average force that acts on the ball times the time interval over which that force acts. So this is the standard impulse relationship. So this is going to be equal to P final of the ball minus P initial. Clearly the wall isn't moving, so we don't have to worry about the wall's momentum. And since the magnitude of the velocity is the same in both cases, then the magnitudes of these things are the same. And so let's look at this in sort of pictorially. So if I have a ball coming in from this direction with some speed, and then it's going to hit the wall and rebound going in the opposite direction with the same speed. And so if I define a coordinate system here, I have to give some positive or negative direction. So let's call the rebound direction positive so that I can really take into account the fact that the velocity has changed signs. So that would mean that my original momentum is negative because my original velocity would be negative. And so the final momentum would be positive. So I would have mv, which would be my final momentum, minus a minus mv, which is my original momentum. And so the change in momentum is twice the absolute magnitude of the momentum during the collision. And so this tells us then that the average force is going to be equal to the change in momentum over time. So that's 2mv divided by delta t. So that is our average force. And so then the second part of the problem says, so this was A. The second part of the problem says, well, evaluate this numerically, given that the ball has a mass of 140 grams. It's moving at 7.8 meters per second, and the duration of the collision is 3.9 meters per second. And so part B, all we really need to do is to put numbers into a calculator here. So we know that the average force is equal to twice the mass of the ball, so that's 0.14 grams. It was moving at 7.8 meters per second, and the time of the collision is 3.9 milliseconds, so that's 3.9 times 10 to the minus 3 seconds. And so if you multiply all of that out, you get 560 newtons as the average force that the wall exerts on the ball or the ball exerts on the wall. They're equal and opposite.